So this is my introductory video on antiderivative. So what's an antiderivative? So we know that if you know the distance function, if we differentiate it once, we get velocity. If we differentiate it two, we get acceleration. So we know how to go from distance to velocity to acceleration. Suppose we want to go the other way around. Suppose we know the acceleration. We start here. Or suppose we know the velocity and we want to get back at the distance. So we need to do the opposite of differentiation, clearly. And that is called anti-differentiation. So, so let's look at an example. So suppose we have a function f of x, small f of x is equal to 2x. So we want to find the antiderivative of that. So we are asking what function will give you 2x when you differentiate it? Well, clearly you know a function that will give you 2x. And what's that? X squared. So that will be a antiderivative of 2x. So 2x, so when x squared derivative is 2x, so therefore x squared is antiderivative of 2x. But here, and then similarly, if you take 2x squared, what will be the antiderivative of that? Well, if you differentiate x3, right, we do that. But at the same time, it's not just x3. If you take x3 plus 2, or then the derivative of that is also 2x squared. 3x squared actually. So 3x squared. So the derivative of x cubed will be 3x squared. But if you take the derivative of x cubed plus 2, that will still be 3x squared because the 2 is a constant that will disappear. So it's really not fair to say that x cubed be the general antiderivative. You can actually have a constant. So you can have 3 or you can have 5 or you can have 7 or whatever, right? So in general we say that the antiderivative is x cubed plus c. We add a constant just to make sure. All right, now suppose we want to find the antiderivative of x squared. So we like to suppose, you kind of think that x3 might be the antiderivative, right? But if you just take x3, we the derivative of x3 is not x squared because you get a 3 in front. So you need to actually to get rid of this 3. How do you get rid of this 3? You divide by 3. Well, now you know that if you take this one, what's the antiderivative of that? So you have x to the 3. When you differentiate, you get 3x squared, but you have 3 at the bottom also. So that 3 and this 3 will cancel off, and you get x squared. So from this, you can actually see a pattern, right? I mean, so for example, if you take f of x is equal to, say, x to the 4, if you want to find the antiderivative, that should be x to the 5. But then when you differentiate x to the 5, you get an additional 5 in front. So to kill that off, you need to divide by 5. So now you can see a pattern, right? Okay. So basically, if you have x to the n here, right, n to the n, then what you do is we have 4 here, we go up to 5, and we divide by the new power, right? So if you have n, the antiderivative will be x to the n plus 1, go up 1, and you divide by the new exponent. So if n is 7, for example, it'll be what? 7 plus 1, which is 8, divided by x to the 8 divided by 8. Plus, of course, there's a constant. See some examples. So if you have x to the 50, if you want to find the antiderivative of that, so 50 will go up by 1. You get what? 51. And you divide by the new power, which is 51, plus c. How do you do something like 1 over x squared? Well, even though it looks like 1 over x squared, it is still a power. What power is that? X to the negative 2. So what we do is we take negative 2 and we add 1 to that, and then we get negative 1, and we x to the negative 1. So we get x to the negative 1 divided by negative 1, which is negative 1 over x. Then 1 over square root x, then we have what? That's actually x to the negative 1 half. So we have negative 1 half. We add 1 to that, and then you get positive 1 half. And you divide by positive 1 half. And then when you divide by that, the 2 goes right to the front, you get 2 square root x. So we can actually use the the power rule, except there's one condition. The power has to be not equal to -1. Why is that? Because if you have -1, then if you add 1 to -1, you get 0, which is fine, x to the 0. But when you divide by that new power, you get actually division by 0, which is not allowed. So it's be very careful that you don't divide by 0. So when you're using the power rule, you must make sure that the power of the function, the power of x that you're starting with, is not equal to -1. So for example, if it is x to the -1 or 1 over x, this formula will not work. So this formula will not work if you want to find the derivative, antiderivative of 1 over x. Thank you.